to go over to the wrench and click on show grid. Okay. It'll just be a lot easier to deal with. Then when you make your triangles, I'm going to do what in my opinion is the more simple triangle first. And so what I would do is I would click on the polygon, okay? And if you hover over close to the intersection, it'll go right on the cross, which will be pretty helpful here. So if I just make this like a 3 by 3 or something, you can do whatever you want. I would recommend an isosceles triangle though. Okay. Now, my advice would be to go ahead and label all this stuff. And we found a nice little trick. If you press the select button, and then you come here and highlight everything, you can press label and it's going to label those measurements and the points, which is really nice. And I want you to change two things here. I want you to click on this point B, and I want you to call that my center of dilation, my COD, if you want, a center of dilation. And I also want you to click on the 4.5. And I want you to get rid of that because it's the area, and we're just not going to worry about that for today. Okay, so start with a situation maybe like this, and I'm going to put in the rubric that you cannot do a 3 by 3. I would actually recommend doing like a 2 by 2 or something smaller. Also in the rubric, I'm having us do a triangle that's scaled up by a fraction, so not just doubled. So don't just come up here and make this a 6 by 6. Please don't do that because I want us to get practice with actual fractions. Okay, so make sure that it will be not a 6 by 6. Make sure it's not just doubled or tripled. We're trying to do actual fractions here. But let's say I made it like a 5 by 5. So if I start at the center of dilation and count up 5, come down to the center of dilation, and then I go over 5, we get this situation where it's a triangle kind of embedded within another triangle, which we need as much practice with as we can. So again, I'm going to go ahead and select all this and label it. And now everything is labeled. So unfortunately, it got rid of that center of dilation. So let's go ahead and fix that center of dilation, and then we'll delete those areas. Wish dilation, which is the 4.5 and the 12.75. And what I want you guys to see here is that my scale factor in this case is gonna be 5/3. Okay, if I set up a proportion, I could see that. Or if I just take out my calculator and I see what 5/3 is, if I multiply that times 4.24, I should get that third side, that 7.07, which in fact we do. So again, we want a situation like this. To get full credit, go ahead and label your angles. And then there's going to be one last interesting thing here. When we have a situation like this, where we have our triangle embedded within the other into one of those corners, um, it's pretty cool that we can see um, that these are going to be similar. Okay, and this is how. When the lines are parallel and it's tucked into one of those corners like that, we know that this is going to be a similar triangle situation, because if I click on more tools, parallel line, choose a line to select the slope, I'll pick either of these. Choose a point to set the location. So I have less points. I'm going to pick either A or C. And notice that these lines are parallel. Okay, they're not going to ever cross. That's what we wanted there. Okay, and again, 45 45 45 45, remember those are called corresponding angles. Just so we're not confused, that 5 really is with that entire center of dilation to E, and then this 5 over here is center of dilation to D. It's that left side. Okay, just in case you're like, what do these numbers mean?